This video presents the eCAR solution developed under the first open call of the H2020 XR for All project. Augmented reality frameworks basically are based on having visual cues, which are called markers, that are recognized by an AR application. The recognition of a marker triggers the retrieval and the display of the information that has been associated to the marker. This information can be static, for example the title of a painting, or can be dynamic, for example measures coming from a sensor. Anyway, the information is statically tied to the marker and it is independent from the user. Therefore, all users get the same information. How could we differentiate the information when the context is the same and the visual cues are the same? The traditional approach is to duplicate the information as it is depicted here. eCAR explores a new area that combines augmented reality technologies with new encryption techniques. This combination enables the development of augmented reality applications able to customize the provided information not only according to the marker, but also taking into account the characteristics of the user. The customization is based on a new cryptographic approach that is called CPAB, Cipher Text Policy Attribute-Based Encryption. CPAB is an asymmetric cryptographic scheme. The encryption process is based on an access policy that, by combining a set of attributes, specifies what kind of characteristic a decryption key must satisfy for the description process to succeed. The access policy is used to encrypt the information, so, the same information encrypted with two different policies generates two different encrypted data. Each user has its own decryption key. Users' keys are generated based on attributes associated to the users, for example taking into account the attributes in the user profile. Therefore, if these attributes satisfy the condition that are stated in the encryption policy then the decryption process will succeed, otherwise it will fail. eCAR uses this encryption technique to protect the information and differentiate it according to the user profile. What we have developed are components that can be used on the mobile phone to support this kind of information customization and a set of tools that can be used for creating and managing the encryption policies, for encrypting static data, like PDF files or other kind of documents, using created policies, or for encrypting dynamic data, for example coming from sensors. Additionally, in eCAR the data owner can create the metadata information to be associated to a visual marker. This metadata information can combine one or more data sources that can be encrypted or unclear. The components that have been developed within the XR for All project are the JSON schema that must be used to structure the meta information to be associated to markers, a set of software libraries to be used with the Android eCAR framework to manage the encrypted information associated to markers, a WYSIWYG web application through which you can manage the access policies. You can create instances of the meta information to be associated to the markers, or encrypt static data sources. The web application is also able to manage the markers to be recognized by the eCAR application. Finally, we have software modules for encrypting dynamic data, so you must use this kind of libraries for encrypting the data that are acquired, for example, from sensors. All the components are provided as open source and the code is available on the XR for All development portal and specifically using this URL in this slide. This slide shows a mock-up of an eCAR enhanced application. What we will see is a virtual scene with a marker on the table. In the simulation we will see a mechanic worker reading the marker and getting some information about the engine. Afterwards a supervisor using the same eCAR application reads the same marker but gets additional information as compared to the initial worker. This slide provides a quick overview of the web application through which you can manage the access policies. This application provides a drag-and-drop UI that is based on the Google Blockly framework. On the left pane you have a set of logical operators and a set of attributes that you can select and drag on the central pane. On the central pane, combining the operators and the attributes on the left side, you can create even complex access policies. On the right side we provide a file system-like pane where you can save policies. Of course, you can edit existing policy and modify them. The web application can also be used for creating the meta information to be associated to our markers. This meta information can reference one or more data sources. A data source can be a static one or a dynamic one. It can be unclear or encrypted, it can be embedded or referred. An embedded data source means that the actual content is included in the meta information instance, while a referred one can be accessed via a URL. Of course, you can also select an access policy through which you can protect the information.